This is a series of videos based on the book, Cases on Teaching Critical Thinking Through Visual Representation Strategies. The book is co-edited by Lenny Shedletsky and myself, Jeff Beaudry. We're both faculty members at the University of Southern Maine. This video is about a topic, teaching critical thinking to first-year medical students through concept mapping. The chapter was written by Dr. Amina Sadik from Touro University in Nevada. The questions that you might think about as you're watching this video are as follows. How are the mapping strategies integrated with the case studies for medical students and teachers? How are the rubrics or assessment tools used as formative and as summative tools? Formative being for learning and summative being for grading. What was the connection between group processing skills, critical thinking, and mapping strategies?
Dr. Amina Sadik has joined us, and she is from the Touro University in Nevada in the Basic Sciences Department, and has been one of the, most delightful student-teacher relationship. She has began when I was teaching online courses in classroom assessment and in research methodology, and I used mapping, and Amina was quickly very, very engaged in the process and went on to then do so many wonderful research projects with this, and ended up writing a chapter in our book. And I'm so very pleased that she's here today to present her case study in teaching and concept mapping. So welcome, Amina.
Well, thank you, and I really thank you for giving me the opportunity to participate in this webinar. Yes, indeed, for me it was a great discovery. When I started taking that was 2009, I remember very clearly, and I was away on vacation in Morocco, and I had to do all my homework, but I really enjoyed doing it. It was not trouble. So every basic scientist teaching in medical school, it is really, really very challenging to make student or medical student understand that someone else is playing with my slides. I think.
I don't know. Is it? I'm not. Lenny, are you?
It's moving. It's moving.
Lenny.
Okay. Hello.
Is that Lenny? Did you do that?
No, I did not.
Okay, I don't know, but it is moving. At any rate, I was saying that I was looking for a way to make a student understand a basic science material is absolutely necessary in the practice of medicine. And if you are just lecturing and giving them exams once a while, it really doesn't send the right message. And when I was exposed to concept mapping the first time in 2009 by Jeff, I said, this is it. This is it. This is a way to visualize. People would not say, oh, if you know something, you can show me that. But in fact, you can through concept mapping. So, and as I said earlier, it is very, very difficult to show the student the connection between all these basic science disciplines and the practice of medicine. Moreover, in medical schools, I have noticed that formative assessment is not really something that everybody focuses on or even know about. We give these mind-numbing lectures, and then we give all these questions, and they don't have a time in between to see, okay, if I don't know, what do I do now? So formative assessment and concept mapping, I consider that absolutely a tool for that, or wonderful tool to do that. So again, they give them an opportunity to visualize what they know and receive feedback, and consequently get ready for summative assessments. So I definitely share this with students in the beginning and tell them why it is important to concept map your knowledge when I give you a clinical case. And I show them that visualization and our eyes are the main probably, or is the main sense for us in learning, as indicated in this table. And moreover, for someone, I went to this conference where someone talks about brain rules, and that person focused that when you chunk or group or put a circle around something, the brain tends to remember it better. And if you add a color, it's even another tool to make that stand out from this mass of words in the same color. So we do take advantage of that when we are mapping a clinical case. And this is, I took this from your lecture, Jeff, and where the concept mapping fits in the literacy. And yes, literacy is what you read, what you write, and what you visualize using technology. And of course, I'm one of those that use technology, but I don't use it to just use technology, as use it so that if it's going to enable students to learn better and enable me to teach better, and of course as a tool to assess students. And this is what I just said, but I put it in again a concept map. When I give that introductory lecture to the medical students in the first session of medical biochemistry, I use a lot of concept mapping to summarize what I'm saying, to tell them, you know, you can take a lecture that is 24 slides and put it in one concept map. And I do that for every lecture. I have at the end of the chapter a concept map of what I have taught them, and make it clear and organized and very easy to see, and organization and connections for the brain. It makes things absolutely easier to retain instead of having these retention of material that is easily forgotten. So definitely this helped us make students understand, and I'm not sure I put a slide here in this presentation, but it is absolutely I put it in the chapter, that I compare the result or the performance of students on step 1 board exams before and after introducing concept mapping and clinical cases through concept mapping, and how logically you can, using your critical thinking, you can organize the thought and concept, what led to what in a patient presentation of a disease through the concept of medical biochemistry, help students retain the material matter and perform better. So it's definitely, as I said, a wonderful tool for formative assessment, because that gives them a chance when they meet with the faculty, they first meet together. I'm going to talk about that organization. So we definitely start making our lecture interactive, meaning we have, for myself, I have every 5 to 7 slides, I have a question. That question can be from the material that I just talked about, or can be from a material that we talked about previously, but it is a base for what I'm talking about that day. And then, in order to even enhance the understanding of the material of that week, we find or we create, I'm working on a case, for example, this week, I have been working on it for a couple of weeks, on metabolic syndrome, to concept map metabolic syndrome and the relationship between what leads from one thing to the other, so that the patient end up with the diagnosis of metabolic syndrome. So we find those clinical cases, or we create them. They have to address what we are trying to teach that week. And yes, we do absolutely have specific objectives for that clinical case, and these objectives just say what you need to know ahead of time in order to understand the case. We give them guiding questions, and these guidance questions are meant to push them to read the material we are giving them, whether included in a lecture or specific to the case. And these are resources that they have really to go and open them and read them to find the answers to these questions. Then the last, of course, we give a rubric of the concept map so that they know what are the expectations, and they have to put that concept map together in order to earn whatever grade they are looking for. So they know our expectations. I want to share with you that rubric. And yes, the student have to, I group students between 5 and 7 members of every group. Then I tend to call them leader team, because they really get to work together for a long time and they become more efficient. And that concept map, we give them like 3 days and a half, and they have to come and talk to us and present that material and justify the connections. And by adding note, and I don't know, guys, if you showed any concept map with note, but adding note to explain why the connection is made at that point, and why not earlier and why not later between all these concepts. And they receive feedback from us. We do not give them directly the answer. We ask them the questions so that lead them to find the answer on their own. At no time really we give them any answers. We give them hints, we give them questions, and we can start from the upstream going downstream with those questions, and one of them or 3 of them at the same time will give you the answer right there and then. So definitely the flow helps in understanding the material. By the way, this is the rubric. By the way, I learned the concept map and the rubric at the same time from Jeff. And of course, I modify it 1 year after the year. I think probably it became stable only the last 2 years, because every time there is something or comment from a student, well, I did not know that I had to have all my connecting words. I did not know that I have to add modifiers within the bubble to tell you what happened to that compound in the blood of the patient. I thought you would understand that, yes, the pH has decreased. Yes, definitely. Now we are in acidic situation, etc. So now it's stable. There's no comment. Everything we expect, it's there. We talk about, yes, we want you to complete all the bubbles. We want you to show us the relationship in a logical way between all these concepts. And yes, we want you to explain using a note, why did you make that connection and where did you get it from? Every bubble, every note has to have a reference, whether it's a reference to a lecture or a slide number from so-and-so's lecture, or it's from a reference that we gave them or they have to find. And those references have to be credible and reliable. I definitely I don't like Wikipedia, so the student knows that and make them laugh, because I tell them that sometimes pizza guy may have been editing the information. And so up to date, we give them certain references that they are going to be called to use in 3rd and 4th years. So they have to be used to using those references. And of course, we added this, that was the last thing we added, timeliness. We want the students to turn in their concept map on the day of the workshop by 6 o'clock or 6 p.m. at the end of the day, not the following day, not 3 days later, absolutely that day, because we don't want to give them an advantage compared to others to correct or review, or we want them to give us what they have come up with as a group at the end of the session, send and submit that concept map. So this was the last thing we added. Of course, at the beginning of the class, we give them a template and we tell them what we want to. We are not trying to teach you physical diagnosis. We are trying to teach you how do you explain a specific disease using the biomedical concept? Tell us what is the underlying biochemical, whether it's a genetic, whether you know, even if it's genetic, tell us if it's a point a mutation, if it's something coming from the parents, is it coming from both of them, if it's not, or sometimes just tell us, okay, we know it's a deficiency in this enzyme, and we go from there. And yes, the managements come early, but generally I tell them I would like to see where really the drug you are using or the diet modification you're going to advise, I want it exactly linked to where it's going to act. Unfortunately, I can't share another concept map. For example, when they are talking about uricemia or increase of uric acid in the bloodstream, and they say, well, it can be decreased by giving allopurinol. And I said, well, allopurinol gonna do what exactly? Or are you gonna inhibit this enzyme? Okay, and where is that enzyme? It's what level? And it's what leads to the synthesis of uric acid. So I tell them, I want you to add it where exactly gonna end and put it uric acid. It's going to decrease uric acid and is going to inhibit that oxidase. Instead of connecting it, tell me it will help with gout. I don't want to need, that's valid for my mother, but for you as a medical student, tell me where allopurinol going to act and what is the effect of allopurinol on that enzyme. And what can you obtain as product? They're gonna be, tell me that is, show me why it's easier to eliminate from the body a product after allopurinol than just uric acid. So those are examples that we push students to think, why medication, what level, etc. So I am not looking at the questions. So Jeff, there are any questions, please stop me and ask me to answer those, please.
I think we're doing very well, Amina. Thank you.
Okay, so we asked them to point out the changes in biomedical pathways. Tell us if the disease is caused by the absence of the product, or is it a result of an accumulation of the substrate? And of course, every time there's accumulation of substrate, there are things that are going to show in the bloodstream, and also it's going to show in the body, like accumulation when people have this disease called Van Gierke that does not allow the liver, the free glucose, to help rectify the low blood glucose in starvation or just overnight. Eventually the liver gets bigger, and we talk about hyperomegaly. So those things tell them, they go step by step, like, well, I see hypermegaly because glycogen is not degraded, because this enzyme is inhibited, because I see also hypoglycemia because this enzyme is inhibited and it cannot remove the phosphates from the sugar, and consequently sugar cannot get out, etc., etc. So it really helped show the student by mapping what they are talking about, understand what is going on in the body. We do teach them all these pathways, and I'm sure they have been exposed at least to some of them in undergrad. But at the level of medical school, I just couldn't accept. We are just adding just more theory instead to show them the applicable parts of medical biochemistry. That if this does not work, this is what's going to happen. This is how it shows in the body in the absence of health or in the presence of disease. And it's not physical diagnosis, is not pathology, it's medical biochemistry, and we make that clear to them. And yes, they have to explain how to get to the signs and the symptoms, and yes, these are the note. I was referring to note. Every time they say this is a sign or this is the symptom, right, they have to tell us what. Yes, absolutely. Thank you. I forgot about that little arrow. Yeah. Thank you. And not every bubble gonna have a note. But definitely those that need justification, if, for example, they say, oh, this disease is a result of accumulation of the product, a note will be right here to this link to this note, to this bubble to tell us, when you cannot remove this phosphate, it will accumulate, the glucose phosphate will accumulate, and consequently the liver stops degrading glycogen. And the patient, if the patient continues eating carbohydrate, more and more of this glycogen gonna be stored, because that's the only way to go, and we will have more and more of this inflammation of the liver. Okay.
We got 5 minutes, and then
okay, I am close to the end. So this is a visual, and as Lenny was referring to earlier, student makes some wonderful concept maps. I had very little things to change here. Student can get very creative in showing that you really understood what the case about. This is showing sickle cell anemia, not only the I'm gonna put all the bubbles and add all the notes, and of course I close some of the note, otherwise it will be visually very charged here. So as you can see, they are showing where things are happening. The liver, we're gonna show what's gonna happen in the liver. They're gonna show the modification in the rate of reading, hyperventilation, because we find ourselves in a certain situation, acidosis is going to happen. The use things to show we're going to have treatment. So they will show the organ that is affected. Here they are showing the red blood cell to talk, because it will be sickled and consequently will not transport oxygen adequately, hence the crises, etc. And the most creative thing that a student started to do, and now because every one of them transmit second year talk to the first year, everybody now, when there is a modification, some increase or decrease, they use from the icons by inspiration, show increase, as instead of using the word increase, and that shows that they understood that things do increase. Moreover, their brain will definitely remember that, yeah, I remember that increases because we had this arrow that went up, or the other arrow went down, etc. And so they absolutely get very creative in showing the organs that are affected, showing what's have been modified, and organize it visually, which is very important for the brain to retain things. The brain has difficulty retaining things that are in disorder, as has been indicated in that the brain rules. The conclusion is a little bit condensed, but definitely we all know that if students are actively participating in their learning, they will learn better, they will retain better, and more importantly, if we help them make the connections between what we teach them and what they're going to be later, physicians, that will absolutely anchor the knowledge in their brains. And concept mapping is absolutely something that helped us not only help them retain, understand, visualize their knowledge, but also using it as formative assessment, so that when they show us their knowledge, we can give them feedback. They will find out about their gaps, and they have the time to fill that gap before we get to that summative assessment that everybody prepares for and fears.
The chapter by Dr. Amina Sadik, Teaching Critical Thinking to First-Year Medical Students Through Concept Mapping, represents a challenge of bringing together the basic sciences together with clinical decision-making. This is a chapter which has the possible connections with doing authentic learning in high school, where students are looking at in-depth types of scientific concepts, and using concept mapping tools. So as you looked at these three questions, try to think about the way mapping strategies were integrated into case studies or into difficult problems or into authentic learning, in this case for medical students and teachers, and how that might be transferred or connected with the work that you do. The other second question is about rubrics. And rubrics are those tools that we use to assess. And I think we need to make sure that we understand that there's a learning side to this assessment where rubrics are being used to help students probe their knowledge, as well as the summative side where the teachers and ultimately the students understand the level of their mastery of the case studies overall and of their decision making. The target that we're trying to get at, though, is even more broad than that, and that is group processing skills, where we're really trying to accentuate the team building that's necessary and the communication necessary. The critical thinking, which is the contribution of each one of the members, and the mapping strategies. And these mapping strategies are the new component that we're trying to introduce into this world of group processing, critical thinking, and into the authentic decision-making and problem-solving that we do on a daily basis.